Alright, should be a quick video, no intro, whatever. Just there's more of this crap from these fakers, these phony experiments. So the Dispar lab moron, and it's this silly oscillating speed thing. So every time they do one of these experiments, they always start on the wrong side. That is, they're using the side that has the different masses on it. And in this case, you can obviously see the lever's bent. Okay, so the carbon rod is bent. All right, now I repeatedly pointed out how, okay, you have to do this mass thing, where it all has to be the center of mass. You can't have pieces of the mass not centered. And what does he do? He puts a coin on top of the damn thing again. And then we have no idea what this fulcrum is. That's the other, it's really important that between these experiments, you don't change this length at all. So there's no, you don't get to cheat. And, say if the masses weren't perfect, you could just move or slide the fulcrum a little bit over and then they'll balance. But you've changed the distance then. So, so there's just nothing. I mean, they aren't really trying to do the experiment right. And he doesn't try it doing it different ways at all. So he doesn't move the mass in a little bit, move the mass out a little bit, see what kind of oscillations he gets. Nothing like that. You can see that the top image travels higher. Its total height is higher. So it's obviously gotten more energy. And all right, so this garbage experiment that proves nothing. What's your theory? The law of the lever isn't true?
Right, so I'm still using the carbon rod as a lever, but this time I'm using different weights. So these are the weights, little small round weights. There's no additional masses, no additional weights attached to it, just this. This is a one weight for one mass, and then a one mass on the other side. This is a fulcrum, just a little tiny rope string, and then for the two mass I'm simply going to add another one of these next to it very close, and then of course at the half the distance from here, half the distance here. So where's the center of mass? Perfectly in the middle. They are perfectly round objects with a little hole in them, so the center of mass should be at the very center. No more discussion about the center of masses. These weights weigh about 10.5 grams. In the previous video I used these ones. They weigh about 40 grams, which caused a little bit of bending in the carbon rod. So now there should be a lot less bending going on. Alright, so here we have the 2 mass and 1 mass, and as you can see, it balances perfectly. Now the fulcrum is perfectly in the middle of the carbon rod. I have measured it, I've shown you the measurements. Now, if I move the fulcrum a little bit to the left or to the right, then it will become, of course, unstable and it will oscillate faster. I can demonstrate it for you. So when it is like this, when it balances perfectly and the fulcrum is perfectly in the middle, then it will have its slowest oscillation. If I change the fulcrum to the left or to the right a little bit, it will be out of balance and it will oscillate faster. The same if I move the weights to the left or to the right, or this one to the left or the right, it will either, tilt to this side or to the other side, and it will oscillate faster.